The end of lesson 1, you were to do these classwork problems and post it to Google Classroom. Here are the answers. So here's problems 1 through 4. Pause the video so you can look at it more. Those are the answers for 1 through 4 and the answers for 5. And now, lesson 5, properties of definite integrals. So we need to know some rules that we have that we can use with integrals. And one of the first rules is that when the lower limit and the upper limit are the same amount, if you think about that, it's if we were looking at a picture like we did in the previous problems where we had the rectangles drawn, I'd be saying from 1 to 1. Well, you wouldn't get a rectangle, you would get a line straight up and down, meaning there'd be no rectangle, no area at all. So the answer is 0, that we have no area whatsoever. Okay, so that's your first property. Second property is I have a lower limit b to a. It doesn't make any difference. These are arbitrary letters. So I have some number here to here of this function. If I switch the lower limit and the upper limit, then all I do is I just negate the function. So I can switch these from b to a. So if I said from 3 to 1, I could change it to 1 to 3, and I would just put a negative here. In a way, what this is, I see this as reading the function from, this would be from reading it from right to left, because b to a, versus here, if I was reading it, my limits being my x values from a to b, would be reading the area from right to left. So when you read area from right to left, and then change it to left to right, they're opposites, they're negatives of each other. This is where you could split up an integral. So I have some interval from a to b, some lower limit, upper limit, and let's say it was 1 to 10. I could break that up and say 1 to 3, and then 3 to 10. The main thing is that this number here has to be between a and c. Okay, so for some c that's between a and b, we can change this to this method. And then also we can say another one here for c that's a real number, a constant. If I have a constant times the function, you can pull the constant out in front of the definite integral, and that's just a way of simplifying a function to find its integral. Here's another one where if you have two, it could be a function that could be seen as an addition of two other functions. It allows you to take the integral of one part and another integral of another part here. So, next rules. Constant function. The integral from a to b of some constant, like say 7. So 1 to 3 of 7. Well, it's just going to equal that 7, or that number, times b minus a. Remember, this ends up being the width of the rectangle, and in this particular case the height of the rectangle is that constant, because a constant function would have been a horizontal line, and a to b is the distance from one x all the way to another x, and so it gives you the width. This would be the width, this would be the height. Here's an example. If I had from 3 to 7, so imagine on a number line, I have 3 to 7, and then I go all the way up to 2. I have a rectangle, so the rectangle is a 2 from 3 to 7, and so I have this rectangle, and you would find the area of that rectangle, and it would be the height, 2, times the width, 7 minus 3, which is 8. So here's using some properties. So I've been given that this happens to be a fact. From 0 to pi, the integral of sine x with respect to x is 2. And we could work it out and see how it works, but this is a fact. If we then say, all right, let's evaluate, and evaluate a different function from 0 to pi, and that function will be 2 sine x plus 3 dx. Well, we can, first of all, since this is an addition of two functions, I can break it up into the addition of two integrals. And this integral has a multiplication of a constant too, which I can pull out in front of that integral. So now I do the integral from 0 to pi of sine x, which was given as 2. This is a constant, so it's going to be 3 times the difference of those, multiplying it all out, you end up with this. So that's how we might use these couple properties. Here are some integrals that I want you to find and post to Google Classroom. You've got 5 problems to do, and post them and then come back and I will have the answers posted for you.